Well, good afternoon. I'm not Nick Zentner, as you can clearly see. I'm Glenn Cruikshank. I live over that way near Liberty Lake, Washington. It's about 30 miles away. It's behind John Stockton's house. I'm up on a hillside overlooking the Spokane River, which is actually inside of Long Lake right now. But today is a field report on finding the geological pole for the clockwise rotation of the Pacific Northwest crust. Where have we heard that before? So thank you, Nick, though, first of all, for telling us what that is and spending the entire summer and fall teaching us more about that. So this has really been great during the course of the pandemic. So thank you very much, and you're sort of sparked the reason why I'm up on this hillside today on a kind of a cold, snowy day. So Euler poles. So we're going to talk about what's called a Euler pole. And a Euler pole is simply a point on a globe that describes the rotation of a piece of crust. So here's a diagram that I packed all the way up here that shows that this crust rotates, and it rotates around an axis, and that axis is called a Euler pole, or also a geologic pole. So it's called, Euler is, well, he was a Swiss mathematician back in the 1700s. He was kind of a rock star. He did all sorts of math on a lot of topics. He also popularized pi, the 3.14159 pi, not Raspberry Pi or Cherry Pi or Apple Pi. But a Euler pole is just that. So the field report then is because Nick got me interested in the topic of clockwise rotation, and he said it every other session, it seems like. So guess what? I did some research and found yet another report on the clockwise rotation of the Pacific Northwest. So this is a 2017 report by Brocher and other USGS geologists, and they have quite an interesting paper on determining how the Euler pole, or the geographic pole for the clockwise rotation that Nick talks about. So what they've done is looked at both the GPS data that Nick talked about. They looked at faults, and they looked at earthquake centers, and they determined that based on all this data that there is a geologic pole over here by Spokane, Washington. Now I know that Nick mentioned that there are perhaps a rotation pole down by Pendleton. Okay, that may be for one of the plates, but these gentlemen did this pretty massive study about 3 years ago, and using that came up with a Euler pole here near Spokane, Washington. So what they did is looked at a lot of striped slick faults, a lot of earthquake centers, and they came up really with an average. And this average works out to be 47 degrees, 87 west, 107 degrees, 1773 east, which is actually right where we're standing right now, if you can see this. Actually, it's just down over the hill here, but I didn't want to climb all the way down there. It was kind of nasty, rough. But we're in the middle of a clear cut, and we can sort of see around. I'll rotate the camera a little bit, and you can see that we're up on a hillside. The sun's starting to go down a little bit. But it's really pretty up here. Just a little bit of snow on the ground and so forth. But the geographic pole then is something that these gentlemen have calculated as where all of the various piece parts and the blocks of Pacific Northwest are actually rotating. Now, granted, this is not happening very quickly. The Euler point, the rotation is actually measured in degrees per million years. So that's how they measure rotation in this business. And in this case, again, they use the right lateral faults, seismicity, and the GPS surface velocities to figure out that this is the spot where all of western Washington and Oregon, and actually it turns out Idaho, rotate around. So granted, they did some calculations on how fast it rotates, and that's somewhere in here. But if I remember correctly from reading this, that it was somewhere around a half a degree per million years. So if you do the math, half a degree, even an all-way around rotation would be about 750 million years. So it's going to be a while here for that. It's an interesting paper, by the way. Also, I'm reading through this, and I'm impressed, Nick, that you have to read all these things. This had page after page after page of references. I think you could probably print this out and create your own exotic terrain and call it the Zentner terrain or something. But there's a lot of documentation to support this study. What I also found interesting, though, is they looked at the movement throughout the entire Pacific Northwest. Is that even in Idaho, the clockwise rotation in the Snake River Plain, it rotates there too. And if you were standing in the Snake River Plain and doing the study in Pocatello that Nick was doing, you would actually be rotating, heading southwest. So quite interesting in terms of how all of the all this works. So you can probably see, you'll probably have to get the study, but you can see even over in Idaho in the Snake River Plain, there's rotation this way that pivots on the geographic center all the way up here in near Spokane, Washington. So that's a little bit about the Euler Center and the geographic pole for the northwest rotation. By the way, as a technical tip for doing these sorts of field trips, this site is up on private property, and it's a couple-mile hike to get up here. But when I contacted the farmer who's the landowner to get permission to come up here, and explained to him that he had a geologic landmark on his property called a Euler pole, he was like, "Hey, I thought we logged all this and cut down all those Euler poles." Like, no. This is a fictitious, or not a fictitious, but a virtual point in space. But I want to come up, take pictures of it, and just be prepared when you tell them that there's going to be kind of a long pause, like, you're going to take pictures of something that doesn't exist. Okay, I got you. But he was very, very gracious, and I thanked him and letting me up on this property. It's got a beautiful view of the Spokane River. This is just right on a big turn where the floods probably came through here 16 million years ago. I did note that as I lived in Liberty Lake, built a new house here last year, that I now have learned from Nick that my house was built on floodplain gravel, and that the next time there's a Missoula flood, my house is going to basically be in the way. So, but we now know too that it's going to be a few tens of thousands of years before the next flood comes along. So that's a little bit of it on the geographic center here. Again, if you were sitting here for a while, like a few million years, and watched the landscape go by, because this would be rotating clockwise that direction, so you'd be standing here and slowly would watch the land move by as the Earth, or this piece of crust, rotated through around this geologic pole. So what's also interesting for bonus points is, as I mentioned, that the part of the premise for their observations and hypothesis is that that faults fall along radial lines off of this geologic center. So what's also interesting is, as we look here, is here's a geologic map of the area. And there's our Euler point, or our geographic center. Right through here, right down the hill, we can turn the camera, right down there in the gap of the trees is the Latah Creek Fault. And this is one of the major faults in the Spokane area, and it starts right down the hill and heads straight down to the southeast in that valley. So their premise might be right, that this is a pretty good spot for a center if they're basing it on the radius lines and faults that fall along the various radii. And then last, this is mostly, so I've got to look at the rocks around here. We're out there in the snow, and there's not a lot of rocks, but this is probably pretty close. But I'll put this back. But we have what's called silver point quartz monzonite I think I pronounced that correctly. And that's the predominant rock that's in this area according to the map here. This is one of the USGS, Washington Natural Resources geology maps that kind of shows where the what's on the ground here, and you can see the Spokane River that the floods came down this way and kind of cleaned this whole channel out. So, so this is a little bit left over from the old floods as well. And here's a piece of that quartz that I broke off walking the way up here, but you can see it's really quite a kind of a pinkish, fine grain, really hard types of quartz that's kind of found some outcrops around here. So that's my field report on Euler poles, the geological center and the point of rotation for the clockwise rotation of the Pacific Northwest here from high on the hillside above Tum Tum, Washington, which is a little burg along the river right over that way. So thank you again, Nick, for producing these your twice weekly alphabet series. I really enjoyed them. They've been very educational and will probably get me out in the field for this again. So thank you very much. Okay, I got a part 2 for this field report. I now realize we've been watching way too much Nick at Home, Nick on the Fly, Nick on the Rocks at the Crookshank household. My wife Michelle packed a lunch for me, so I stopped to get it out. And guess what's in my lunch? You're not going to believe this. It's fruitcake, the highly balanced meal, and I know this is full of rum. So yeah, fruitcake for lunch, and to top that, we also have in my lunch is a spoon. Got a spoon. Cozy Shack tapioca pudding, a sweet melange of tapioca and sugar. But hey, you gotta love it. This episode this field report brought to you by Cozy Shack. All together now, you gotta love it. Thanks.